Yes, welcome to this next video. In this next video, we'll be doing more questions around integration and finding the volume of solids. So here's a question that comes from the Hilton College past paper, and let's see what needs to get done. So here you've got a diagram, sine, and cos as the two functions, and says without using a calculator, and showing all working, find the volume of the rotation if the shaded is rotated around 2 pi radians around the x-axis. Okay, so most importantly, you can clearly see that our lower boundary in this case is given by x equals to 0. But we then need to find our upper boundary. But we can clearly see our upper boundary occurs at the intersection. So we need to find this particular value. So this needs to occur at the intersection. So let's see if we can find the upper boundary at intersection. Okay, so what happens at the intersection? So at the intersection, we can clearly see it's where the two graphs equal each other. So we can go, it's where sine x equals to cos of x. And then based off of this, we could simplify this by saying this is sine x over cos of x is equals to 1, which is the same as saying the tan of x is equals to 1. And therefore, using our understanding of trigonometry, we'll go shift tan x, and then we get that x will be pi over 4. Remember that we're always measuring this in radians, as the question is stated. So this x value here at the point of intersection is going to be pi over 4. And that will give us our upper boundary. So therefore, if we then have to calculate the volume of this function, we will then come and say the volume is equals to pi. Our lower boundary will be 0, and our upper boundary will be pi over 4. But if we look at this function here, we've got the cos squared at the top. So think about this will be y squared minus y squared. So the volume formed here will be the y squared of this first function. So we can go cos squared minus the bottom function is the sine, which is the square of that because we're trying to find volume. So sine squared of x, everything dx, if you want to put it that way. So because we've got this, it is important for you to realize that this entire expression is a simplification of a double angle. And that's why it's important for you to be able to use identities, because this is part of a double angle formula. And which double angle is it? Check your formula sheet and you will see that the double angle that we're talking about is the cos of 2x. Okay, so once we've got a cos of 2x like this, we should all now be at the stage where we're comfortable with integrating this. So the integral of this particular expression will then be a half times the sine of 2x. And then obviously we then need to apply our boundaries, pi over 4 and 0. And in applying our boundaries, we now get this will be pi. And the first expression will be a half sine of 2 times pi over 4. That'll be the first expression minus, this becomes a half sine of 2 times 0. Applying our boundary there. And therefore, you can see without a doubt that this will end up being 0. And all that we are left with is pi, the sine of pi over 2. So half, we end up with sine of pi over 2. And I'm sure that you've guessed it right. The sine of pi over 2 is 1 because it is a special angle. And therefore, we get that our answer is 1 over 2, or pi times 1 over 2, and therefore the volume of this entire expression is indeed pi over 2. I hope this has made some sense, and it is now becoming a lot easier to solve these questions involving volumes. All right, see you in the next video.